All right, here's a quick introduction to parametric dimensioning. It's basically, instead of putting in a dimension like 2.5, you're going to say, okay, the dimension for this should be relative to something else that already was dimension. So in this first question here, what they're saying is, okay, you got this object, and they tell you that the thickness of D0 is uniform throughout the entire length. What that means is the thickness that it is right here is the same thickness all the way through this arc and back across over here. So the answer for this, we'd say D0 equals, so your answer would say D0 equals the difference of these two dimensions here. So these are both radii. And so we'd say D0 equals D2 minus D1. It's pretty simple. That would be the answer for the first one. This thickness should be equal to the difference between these two dimensions. Now moving on to the next question, because I want to go ahead and show you a little bit of that also. Let's do the first two parts of it. You have an object right here. It's got a hole in it. Okay, so it says, what is the parametric equation for dimension D6? The vertical distance to the hole's center must always be a quarter of the overall width of the plate. So they're saying the vertical, so this dimension D6, what is the vertical distance here? That dimension must always be 1/4 of the overall width. Well, the overall width is D0. So for your answer, you would write D6 equals D0 divided by 4. That way D6 is always a quarter of that. Let's do it together. What is the parametric equation of dimension D1, which is the height of this? Its size must always be half of the overall width of the plate. We would say D1 equals D0 divided by 2. That way D1 will always be half of that width. Make sense? All right.